Welcome back. We are going to look at section 5.3b today. We're solving polynomial equations. Yesterday we looked at solving them by factoring, using the factoring techniques that we've already learned this year. Today we're going to look at a different type of factoring. It's a method called factor by grouping. So we're going to use that to solve our polynomial equations when we have a cubic with 4 terms. Okay? A 4-termed polynomial typically ends up being an x cubed type polynomial. So our first step is to kind of group the first 2 terms and group the last 2 terms. You can use parentheses, you can put a box around it instead, whatever you want. Basically, you're splitting this into 2 parts. Okay? So we're going to look at the first half of it, and we're going to factor out a GCF. So what's a GCF in x cubed minus 3x squared? We could take an x squared out. And we have left over then an x minus 3. Okay? Then we do the same thing with the second group. Okay? The second half of this. Factor out a GCF from that. In this case, we can take out a 4, a positive 4, and we have an x minus 3 left over. Okay? The next step is to take out the common expression as a single parenthesis. So notice that they both have this first half has an x minus 3 that's a factor, and the second half also has an x minus 3 that's a factor. So that's going to come out as my common one. And then I have a factor made up of the leftover parts. And by leftover parts, I mean these pieces. Okay, the things that we had factored out, those GCFs. So I have an x squared plus 4 as my remaining factor. Okay? Then we're going to use our zero product property to solve this. So that's meaning we're going to take each of these and set them equal to 0. The first one we can solve simply by adding 3 to the other side. All right, I don't know why it's doing that. There we go. Okay, so one of my solutions is going to be that x equals 3. For this other one, we are factoring, or we could try to factor x squared plus 4. If it was x squared minus 4, we could factor that. It's a difference of squares. It would factor into x plus 2 and x minus 2. But with it being a plus 4, we cannot factor it. However, we can solve this one by square rooting. We'd subtract the 4 to the other side. Now our x squared is by itself, so we can square root. And don't forget, I put it down as a hint here, remember when we square root, we have to get that plus and minus. And if we're square rooting a negative number, remember it's going to come out as an imaginary answer. So we're going to have x equaling plus and minus 2i. Okay? So our general rule is that the degree of our polynomial tells us how many zeros we should be finding. So my solutions are 3 and positive 2i and negative 2i. All right, let's try another one. Again, we're going to split this up into 2 chunks. You take the first 2 pieces and separate them from the second 2 pieces. We pull out a GCF from the first 2. Again, we can take an x squared from that. It leaves me an x plus 2 left over. Then we look at the second half, the 5x plus 10. We can pull a common factor of 5 out of that, and it leaves me an x plus 2. The part that's left over here, those have to match. If the x plus 2's didn't match, we couldn't factor by grouping. So one of my factors will be that x plus 2 that's common to both halves. The other factor is made up of the pieces we factored out, the x squared and the 5. And now we use that zero product property. We say what makes each of these equal to 0. And we solve those. So for my first one, we're going to subtract 2 to the other side. For the second one, we can subtract the 5 to the other side. But because it's an x squared, we now have to square root. So we are going to end up with x equaling plus minus I because of that negative inside our square root, and the square root of 5. So again, we have 3 solutions. We have a negative 2, we have a plus I root 5, and we have a negative I root 5. That counts as my 3 zeros for my cubic expression. All right. Our next one here, again, split it into 2 chunks. Okay, from the first chunk, we can factor out an x squared, and we have an x plus 5 left. From the second chunk, we're actually going to factor out a negative 3. If we factor a negative 3 out, we have an x plus 5 left over. And again, I had to pull that negative out so that these match. Then we regroup. We put our x plus 5, that's common to both, as one of our factors. And we put our x squared minus 3, the GCF pieces that we factored out, as the second one. Setting them equal to 0. And solving. So we're going to subtract 5 to the other side. On this one, we're going to add 3 to the other side. It is an x squared, so we have to square root. So x equals positive and negative root 3 as my last 2 pieces. All right. You guys can pause the video and try the last one, and then turn it back on when you are ready. All right. Splitting it into 2 parts. From the first part, you should have factored out an x squared and had an x minus 6 left over. From the second part, you should have factored out a negative 8 and had an x minus 6 left over. We regroup. We have a common x minus 6, and we take the factors that the GCFs that we had pulled out, and we have an x squared minus 8. Set them equal to 0, and solve for x. So you should have gotten x equals 6, and for here, x squared is 8, so x would be plus minus the square root of 8. We can break that one down. We can think of it as 4 times 2. So your simplified answer would be x equals plus minus 2 root 2. All right, so one of your zeros or solutions is 6. You have a positive 2 root 2, and you have a negative 2 root 2. All right, so for today's homework, you guys are going to be doing a Delta Math assignment. I do expect you to put work on paper as you're working through that, and be ready to submit that if I ask for it. All right, have a great day.